Alright everyone, so this video is going to be basically on graphing. So we're going to be doing graphing. We're going to be graphing sine, cosine, cosecant, and secant of x. Maybe we'll even squeeze in tangent x, cotangent x. We're going to see how long we can do this. So let's start with them. In the last video I ended by introducing sine and cosine. So I'm going to go back to that and we're just going to revisit them. So I'm going to do sine here, and cosine of x is going to be over here. It's really technically y equals. And I want to give you guys some information about them. Ooh, it's rough. Still a little off, but that's okay. 1, -1, 1, -1. We have 0, pi over 2, pi, 3 pi over 2, and 2 pi. If you want more detailed stuff on this, go to the end of the last video. I went into crazy detail when talking about this. I guess really not crazy detail, but I showed you how it was related to the unit circle. So sine, we had this. This is a little bit squished compared to the end of the last video. And this one looked like this. All right, and again, remember they continued, and I kind of pointed that out. They just both keep going and going and going. Which is fine, but what I graphed here, this one cycle, is what we call a period, and then we have the height. All right, how high and low it goes is what we call the amplitude. So the way you want to think, I like it because it's, to me, it's related to music. When the amplitude gets bigger, okay, it gets louder. So you'd be doing a vertical stretch, right? When the amplitude is smaller and you turn down the amp, it's going to go the other way. It's going to compress. The period of a graph is related to the frequency. So the higher the frequency or the smaller the period, the more repetitions you would have. So the period, two things you're going to have to find. It's related to the x coordinate, and that is going to be 2 pi, because it takes 2 pi for both of these graphs to repeat. It's repeating, starts at 0, ends at 2 pi, and then it's going to keep going. The amplitude, I just usually abbreviate amp, but we can write amplitude. That's related to the y-axis. And with the highest and the lowest number, well, it's just 1. It's always based off the x-axis. Like, how high are you going? How far away are we going? We're going up 1. We're going down 1. We're going up 1. We're going down 1. You know, so it's just 1. So really, there's a formula that I'm going to kind of write down for you. And it's something, if you had to have a sheet to the side, you want to try to keep track of all these, it's definitely something you're going to want to write down. All right, so you have y equals a sine of bx plus c. All right, this is going to go exactly the same for cosine. All right, so this goes for both of these. The period is 2 pi over b. Whatever's in front of x, you're going to put underneath 2 pi. And your amplitude is the absolute value of your a term, or whatever's in front. Okay? So using these, you're going to be able to do a lot. Okay? So let's use them. Let's determine the amp and period. We'll do 3 of them, and then we'll start sketching these things. Everything's going to be based off the general shape, which is what we did above, right? Sine starts on the 0, ends on the 0. Cosine starts on the amplitude, ends on the amplitude. So we're going to use this. And let's do y equals 3 sine of 2x. And all I want to know, hey, state the amplitude in period. I probably should have written that down first, but I squeezed it in there. So, amplitude, easiest thing to find, absolute value of the number in front. So the absolute value of 3 is just 3. The period, well, the period is 2 pi over b, and b is the number in front of x, so it's just 2. So 2 pi over 2, so our period's pi. So we would have our amp being 3, our period pi. We'd be done. Like, that's as hard as it gets. All right. Let's do another one. Y equals negative 5 halves cosine of, let's do x over 2. So my amplitude, absolute value of whatever's in front of the sine or cosine, so negative 5 over 2, or 5 halves. Okay, the period is going to be 2 pi over. Now we have to think, what is in front of x? Well, really in front of x is a 1/2. So here we get 4 pi. You're good. You're done. We'll do one more of these and then we'll move on. So I can already feel some kids just sitting back and like, okay, this is too easy. Like, let's move. Let's just keep going. Negative 1/2 sine of pi x over 3. Don't need an equal sign on that side. So the amplitude, absolute value of negative 1/2, so 1/2. Right. The period, 2 pi over 3. Ooh, dear. So really what happens is you have 2 pi times 3 over pi, which is just 6. So our amp is 1/2, our period is 6. These are going to be the first two things we're going to do when we start sketching these, which is going to be our next example. We're going to sketch a function. So let's try some sketching. This is some sketchy stuff. You see what I did there? Except I think my computer froze on me. Nope. Maybe. Nope. Cool. So it's going to say graph, one period of the function y equals 3 cosine of 2x. So let's first find our amplitude and our period. Amplitude, the number is the number in front, so it's going to be 3. The period, 2 pi over 2, so just pi. So now to graph. The way you want to approach a graph when it comes to trig functions, you really don't even need too much in the negative direction. But you're going to state your amp, then you're going to start at 0, and you're going to end. We always want to have 4 tick marks. Always want to have 4 tick marks. And you want to end at your period. So I'm going to start at 0 and end the period. This will change if they shift left and right. Which it's one of those things, like, I don't even know if we really need to cover it, because it's not that big of a deal in calc, but I think we might do it anyway. So here we are. The cosine graph starts and goes up. So starts at the amp, ends at the amp. Okay, now we have to figure out these missing numbers. The easiest way to do that is to figure out this middle one, because halfway between 0 and pi. So you get pi over 2, because that's halfway between 0 and pi. Then to figure out this next missing one, well, what's halfway between 0 and pi over 2? Well, halfway between 0 and pi over 2 is pi over 4, which therefore means this is 3 pi over 4. Because each, I guess, little distance here is pi over 4. Maybe it's not going to let me erase. Look at that. I think it's time for a new computer. Or whatever. So let's graph it. It's going to start at our amplitude, end at our amplitude. Halfway in between, it's going to bottom out. And then these other points, the reason we want 4 other points is because that's where it's going to cross. So you have your amplitudes, x-intercepts, and you're kind of good. So here it is. This would be considered one period of this function. Y equals 3 cosine 2x. That's all you would have to do. So if I was to grade this in school, the way I would look is I would look for your amplitude, look for your period, and then just the points. You know, I do check for, you know, these things to make sure your tick marks are right or your x values are right. And basic shape. They're kind of heavy-duty questions. So let's do a sine function. We'll do y equals -4 sine of x over 4. All right, so sine kind of looks like that. Okay, starts on the x-axis, ends on the x-axis. The only difference with this one is that it has a negative sign in front of the 4, so you just flip. So instead we're going to be going like that, but we'll see in a minute. You still want to start with the amplitude and period. Amplitude, absolute value of -4, so just 4. And our period is 2 pi over 1/4 this time, because remember there's a 1 in front of that x. So we get 8 pi. So now we go to the graph. Wow, that looks horrible, but whatever. All right. So I'm just going to erase that and redo it. We have to think of our starting points and our points in between. So I'm going to put 4 here, -4. I'm going to start at 0, and I need to end at 8 pi. So I got 1, 2, 3, 4. Remember, 4 tick marks, end at your period. Halfway between 0 pi and 8 pi is 4 pi. And then halfway between 4 pi and 0 is 2 pi. And this other one's going to be 6 pi. So originally what we would have, I'm going to put in green, we would have the points going up like this. And this would be what we would have. But since we have the negative, we need to flip that. So instead, it's going to be in red. We're going to start at 0, bottom out, then come up, then top out, and then end at 0. So really our graph, because of the negative sign, just reflects on the x-axis. And that's one period. So this dotted line crap we really don't need. Okay. Let's see if we can do a few more of these. And then I'm going to show you what happens when you... Oh, I forgot something on our general equation. I'm sorry. Just to go back to it. you can always say plus D. Because if you add something to it, it just shifts it up and down. All right, so the C is left and right shift. I never even wrote that down. And the D is up and down shift. Oh, man, that would have been bad. Oh, dear. Oh, dear. Okay. Sorry about that. So let's try another function. Yeah, I don't know which one I want to do. Let's do this one. I have so many different examples in my notes, it's not even funny. Y equals negative cosine. Okay, so then that means instead of starting like that, I'm going to go the other way. Okay, we'll do pi x over 3, and then we'll add 2. Okay, so we still want to do our amp and period. Amplitude is going to be the absolute value of negative 1, which is just 1. Our period is 2 pi over 3, which is just 6. And now to graph. I'm going to put my x-axis a little bit lower this time because I know I'm shifting up 2. So I'm going to kind of do that. And I'm going to say that this is negative 1, this is 1, that's 2, and 3. And then I get 0, and I have to end 1, 2, 3, 4 tick marks at 6. And so my halfway between 0 and 6 is 3. Halfway between 0 and 3 is 1.5, or 3 halves. And then halfway between 3 and 6 is 9 halves, isn't it? Like 4. Right. So originally what we would have would be starting at negative 1, ending at negative 1, because it's upside down, topping out at positive 3, and then crossing through. So we would originally have something like this without that plus 2. But then what we have to do is take this whole graph and shift it up, well, not just 1, but 2. So we would have a point, and a point, and a point. There it is. That'd be it. That would be your answer. Right? You would have that nice little curve, kind of like a roller coaster. Great stuff. And then the reason I have to show you guys this stuff is what's going to happen in calc. You're going to have to figure out, what this angle is right there, or what that angle is. Basically, they're what's called the average rate of change or instantaneous rate of change. Everything kind of deals with slope. It's really weird. But yeah, the left and right movement, I guess we can do. Maybe we won't really touch on it here, because I want to show you guys cosecant and secant before we actually finish this video. I don't think we're hitting tangent on this one. So y equals cosecant x. Then we have y equals secant x. Well, cosecant is related to sine x, and secant is related to cosine x. So the way we approach these is you first graph as if function is reciprocal. The reason, what that means, is you want to, it's to graph instead of saying, so if I have like I don't know, let's just pick an equation. Just for an example right now. Don't worry about going crazy seeing what this means yet. But if I said the cosecant of, let's say 3 cosecant of 2x, well, the way I would approach this is I would first graph y equals 3 sine of 2x. Because if I graph that first, then I can do the reciprocal really easily. All right, so graph that. That's good, and then we'll go from there. They're kind of funky graphs. So let's first graph y equals sine x. They all still have amplitudes and periods. Okay, the amplitude is 1 in this case. The period is 2 pi because it's 2 pi over 1. Same thing on this side. Period. Okay. So, if we're going to graph this now, well, that looks gross, but it's going to work. Remember, we're going to start with the sign on this one. I'm going to start at 0, 1, 2, 3, 4 tick marks, end at 2 pi. Get my points, and I'll make my sine graph. But I'm not going to connect it. The way that I'm going to do this is with a dotted line, actually. Just so I can have it, because everything's based off of that. Now what we do is you're going to make vertical asymptotes. At the x-intercepts. So wherever there's an x-intercept, we're going to put a vertical asymptote. All right. So that means I can't touch 0, I can't touch pi, and I can't touch 2 pi in this example. So all I have left are these 2 points at pi over 2 and 3 pi over 2. And the graph is actually a parabola shape from each one of those points. All right, so you're gonna have some funky U-looking things. So here's the sine graph. If I can graph 1 divided by sine x, I wonder if it does it well or not in here. Let's see what happens. Can't even graph it on this calculator, isn't it? Oh, I put 0, you moron. Let's see. There's the sine graph. Oh yeah, there it is. Hey. But, alright, so let's take the sine graph off, just so you don't see it. Actually, let's see if we can make it dotted. Hey, does that work? No, it's still a nice looking graph. All right, but so your sine graph's there. You can kind of see what's happening. And what we just graphed was this U up there and this one there. And that's really all it is to it. So if we were to turn this one off, we would have our cosecant graph with the U's, which is great. So let's do our secant graph. So you're going to do exactly the same step. We're going to graph the reciprocal first, so which means we're going to graph cosine of x. I'm going to start at 0, 1, 2, 3, 4 tick marks, end at 2 pi, this is pi over 2, 3 pi over 2, 1, negative 1, make my dotted one. But the same exact thing's going to go. Any x-intercept, you're going to have a vertical asymptote. So now what that leaves us with are points at 0, pi, and 2 pi. So sketch towards the asymptote. So every time I graph this, all I can see is like a dog face. Like here's like the snout near the eyes. I don't know. It's just maybe I'm just weird. But that'd be it. Obviously, this does continue over here. You don't have to worry about that, but you can if you really want to. But that's our it's our secant graph. You would follow exactly the same thing if you were to shift them left and right, up and down, different amplitudes, different periods. Everything's exactly the same. Just follow those 2 steps, and it shouldn't be that bad. So graph the reciprocal, find the vertical asymptotes, and I guess the last step is to kind of sketch the parabola shapes. So let me see if I can move those down, just so you can read them a little bit better. So graph is the reciprocal function, vertical asymptotes at x-intercepts, and then the last step, make the sketch and shape of parabola. Yes, there are reasons behind doing all this stuff, and it's a bummer that we're not in school, because I could actually go into detail with the reasoning behind it. But I don't really want to touch on that without doing a whole lesson on it, and I think, time permitting, we're not going to be able to do it. So yeah, the only other 2 things we have to do is tangent and cotangent, and I think I can introduce you those, because I think I have a few more minutes here before the half-hour time, my half-hour time limit's up. And don't worry about being perfect with your graphs. Again, we're not in school for us to be able to, for me to help you and guide you through, like, basically student by student, to do this. Right now I'm kind of just get you to see these, so you're not surprised if you see them again. I already talked to the other pre-calc teachers, and we're gonna have to talk to Mr. G and Miss Crane's teaching honors calc, just so they know how far we got in pre-calc, because there's going to be things they're going to have to teach you, because we're not going to be able to cover everything. So we have tangent and cotangent. Both of these, there's no amplitude. Okay, the period for both of them is pi. It's always a distance of pi. And both of these actually have vertical asymptotes. Right, both of them do. So tangent, since there is no amplitude, since the period's always pi, all right, well, we assume it's pi. It's going to be a little different in a minute, because, again, depending on what's in front of x, you have to find your vertical asymptotes. So to find it, you take whatever you're taking the tangent of, make it equal to pi over 2, make it equal to negative pi over 2. All right, now with cotangent, you make it equal to 0 and pi. So those are like the 2 differences. You're going to have to just remember those, or jot them down, obviously. So if we were to graph tangent, I'm going to put a vertical asymptote, negative pi over 2, pi over 2, halfway in between, I'm going to put a dot all the time, halfway in between. And then I make a snake. So that's your tangent graph. Now if I was to do this for cotangent, well, think about what cotangent is. Cotangent is a reciprocal. So reciprocal is going to have a little different looking graph, but not by much. Halfway between is going to be my point, but I have to state that point. In this case, it was 0. In this case, it's pi over 2. So instead of my snake going like what I have for tangent, I go the opposite way. And that's your graph. Okay? It doesn't really get that much harder. The only thing we would have to change is where we find those asymptotes. So I know I'm over my half-hour thing, but I want to do one where you find the asymptotes, just so you guys can see that, you know, it's not always 0 and pi, or negative 2 pi and positive 2 pi. So let's say we do the tangent of 5x. So you just need to find your vertical asymptotes. You're going to make 5x now equal to pi over 2, and 5x equal to negative pi over 2. So before I just had x equals, and I didn't have to solve anything because I already knew what x was. So here I have to actually solve for x. So I'm going to divide both sides by 5, and I get x to be pi over 10. And in this case, I get x to be negative pi over 10. So once you have those, I put them on. Negative pi over 10, pi over 10, put a dot, make the snake. You're done. That'd be your graph. If I put a negative sign in front of tangent, right? If I put a negative sign in front, your graph would just go the other way. It would just be shoom, like that. We could do those again, but no really need to. Could you plug these in your calculator? Totally. The key is just to find the asymptotes and then get that point in the middle. There's really not much else to those. All right, so we'll call it quits on this. Maybe we'll revisit the graphs again because I want to make sure I'm really comfortable with those. Well, comfortable to an extent. Yeah, and we should be good. If you guys have questions, come to the Hangout or Google Meet, whatever the heck you want to call it. We can talk about them. All right, have a great week. We'll see you.